Hello everyone, welcome to video 6 of one-way ANOVA. And in this video, we are going to look at the post-hoc tests or multiple comparisons, evaluating the differences between liberals, moderates, and conservatives. In the last video, we went through and completed the first two paragraphs of the write-up. And now we're moving on to the post-hoc tests. To see exactly how liberal, moderates, and conservatives differed in their levels of anti-feminist prejudice. And so on the screen here, we have the post hoc or multiple comparisons table from SPSS. And you might notice that it seems maybe a little bit bigger than it should be because we have three groups and we should only have three comparisons. Right. So there is some redundant information in this table. And so as we go through, I'll point out why there seems to be more information here than need be. Right. Okay. So let's first look at how liberals and moderates significantly differ, because that's sort of the first comparison. If we start from the top and work our way down, that's the first comparison that we're making. So here we're comparing liberals to moderates, drawing an arrow here. And so we're going to concentrate on looking at whether these groups significantly differ. And so our p-value here for this comparison, the liberal-moderate comparison, is the p equals 1, right? So p-values are significant if they're less than or equal to 0.05. We are as far from 0.05 as we can go here. P equals 1. So liberals and moderates do not significantly differ. No, p equals 1.00. Right? And you'll notice that we could have gone from liberal to moderate here, right? But they also, in the table here, you could have easily gone from moderate to liberal instead of liberal to moderate. So here, as you can see, we could have gone from moderate to liberal, right? And that would still give us the same p-value here. But you'll notice that from liberal to moderate, as you can see, if we look in the mean difference column here, if we go liberal to moderate, meaning if we take liberal, the mean for liberals minus the mean from moderates, we would get a difference of negative 0.04, right? But if we went from moderates to liberals, you see that the difference would be positive. So if we take the moderate mean minus the liberal mean, we would get a positive difference, 0.04. So moderates do have numerically a slightly higher mean, even though those means are non-significantly different. So how do liberals and conservatives differ? Do liberals and conservatives significantly differ? We already know the answer to this question, but it's the next comparison that we should make if we're starting at the top and working our way down here. So if we go from liberal to conservative, we see that the p-value is 0.001, equal to 0.001 exactly. And so, yes, liberals and conservatives significantly differ. And again, there's a redundant comparison here. So we could have gone from conservative to liberal, and that would have still given us the same p-value, except the mean difference, right? When we go conservative minus liberal, the difference is positive. But if we go from liberal to conservative, the mean difference is negative, because conservatives have the higher, numerically the higher mean score here. So we know that liberals and conservatives significantly differ, that conservatives are reporting more anti-feminist prejudice compared to liberals, just as we saw in the independent samples t-test. Now for our last comparison, we've compared liberals to moderates, liberals, conservatives. Now we need to compare, right, conservatives to moderates, or moderates to conservatives. And so as we make our way down here, we'll compare moderates to conservatives, and we go over and we see that the p-value is equal to 0.001. And so just as for the liberal conservative comparison, the p-value of 0.001 was significant, the p-value here for the moderate conservative comparison is also significant. Conservatives and moderates also significantly differ. And this is what we sort of guessed after in video 3, we looked at the mean differences between liberals, moderates, and conservatives, and it seemed like liberals and moderates were scoring similarly, while conservatives seem to be reporting more prejudice compared to liberals and moderates. And so the post-hoc comparisons table confirms our first glance of the mean scores from video 3. And we can see that conservatives are scoring higher than moderates. If we look at the mean difference here, right, moderate minus conservative, that would give us a negative difference of negative 1.49, right? So if we take the moderate mean minus the conservative mean, that would give us a negative mean difference. So we know that the conservative mean is higher than moderates. And again, we have that redundant comparison here. We can go to conservative to moderate, just as we can go from moderate conservative. We can go to conservative to moderate, and that will still give us the same p-value, but in this case, the mean difference is positive because we're going conservative mean minus moderate mean. That will give us a positive difference because conservatives numerically have the higher mean score. Right, so that's it for the post-hoc table and interpreting which groups significantly differ. Here, liberals and moderates do not significantly differ, but conservatives are reporting significantly more prejudice compared to both liberals and moderates. But just because we have a significant difference, significance does not equal importance. And so we have to calculate the Cohen's d values for each of these mean comparisons. So we're going to have a d value for the liberal moderate comparison, a d value for the liberal conservative comparison, and a d value for the conservative and moderate comparison. So let's talk about how to calculate Cohen's d. So the general equation here, the general formula for calculating Cohen's d is just like the independent sample t-test, in that we're going to take the observed difference, the mean difference, and we're going to divide by S pooled, spooled. So if you remember correctly from the last unit, S pooled, right, means that we are pooling the standard deviations for the independent groups. Right, we're calculating an average, in this case, a weighted average of the independent group's standard deviations. And so if we go quickly back to look at the mean scores here, and standard deviations for the independent groups, right, we're going to create a weighted average of these standard deviations for the independent groups. And we can't calculate a simple average because the n's are different for the independent groups. The n's, the little n's for each of the independent groups, are not equal. So we can't just add these standard deviations up and divide by 3. And you may also be thinking, well, can't we use this total down here? No, this total standard deviation is calculated with the entire sample, right? Here, we're going to first calculate, well, SPSS has already done this. SPSS has calculated the standard deviation for each group, and from here, we're going to calculate a weighted average. So you can't use the total here either. And unfortunately, we can't use the Lion-Morris website to calculate Cohen's d, right? Because the Lion-Morris website only allows us to enter the results, the mean standard deviation n, for 2 groups at a time, right? We need to calculate an S pooled value that takes into account all 3 standard deviations here for liberals, moderates, and conservatives. Luckily enough, there's a really easy way to calculate S pooled using the ANOVA table. So we're going to move forward back to our slide. Bam. So there's a really easy way to calculate S pooled from the ANOVA table here, the between subjects effects table. And that is to take the square root of the mean square error. So I'll give you a second to try to find the mean square error in this table. So we find the mean square column, and then we look in the error row. So mean square error here is 3.48. And so if we take the square root of 3.48, that will give us our S pooled value. And so if we take the square root of 3.48, that gives us 1.87. So we're going to take each mean difference and divide by 1.87. Now SPSS has already calculated the mean differences for us, and we can get those mean differences from the post-hoc or multiple comparisons table. All right. Oh, and something that I didn't mention, when we first look at the multiple comparisons or post-hoc table, you can also see not only giving you the depend variable here, but you can see that SPSS is telling us which type of post-hoc test we used here. We used Bonferroni. Sorry, forgot to point that out earlier. Anyways, we have the mean differences here laid out for us. SPSS has calculated those, so we're going to take each mean difference and then divide by S pooled. And so we'll just take the absolute difference here, the absolute mean difference, and divide by S pooled, because whether the D will be positive or negative will depend on which group is listed first in the write-up. Right. So we're going to take each mean difference, divide by 1.87. So for liberals and moderates, right, our first comparison, we're going to take 0.04 and divide it by 1.87, and that will give us 0.02. And then for liberals and conservatives, we're going to take 1.52 and divide by 1.87, and that will give us a d-value of 0.81. And then for moderates and conservatives, we're going to take 1.49 and divide by 1.87, and that will give us a d-value of 0.80. So we have a very small d-value for liberals and moderates, which is unsurprising given that there is not a significant difference between these two groups. And then we have large D's, large differences for both the liberal and conservative comparison and the moderate and conservative comparison. So we have all the information we need now to fill out the third paragraph of our write-up, the post-hoc paragraph. But I will stop this video here. We're at the 13-minute mark, and so we'll stop the video here, and then the next video we will take all the information here and fill in the third paragraph.